laying the groundwork for a new and quieter generation of supersonic flight. From the National Business Aviation Association, this is Flight Plan. I'm Rob Finfrock with your trusted source for business aviation news. And speaking of quieter, you may want to turn the volume down a bit in the next few seconds. That's a sound at least some of you have probably never heard before, at least in person. It's a sonic boom, the noise generated as an aircraft flies faster than the speed of sound. Believe it or not, such booms used to be fairly common across the U.S., particularly near military bases. But as you can imagine, many residents didn't care very much for such loud booms over their homes and communities, especially when they'd result in physical damage like shattered windows. That's why the United States in 1973 banned civil aircraft from traveling at supersonic speeds over land, a prohibition that remains in effect today. Now, that limit certainly stymied the market for civil supersonic aircraft over the next 40 years, but we've seen a resurgence in the past decade of supersonic projects and development, as the benefits of such speedy travel are impossible to ignore. And despite the disappointing news recently that Aerion, one of the commercial efforts to develop a supersonic business aircraft, has shut down operations, government research to facilitate the development of a quieter supersonic jet continues to move forward. Today, I'm pleased to welcome three engineers on the National Aeronautics and Space Administration's Low Boom Flight Demonstrator project. Kathy Baum is Deputy Project Manager. Gautam Shah is Sub-Project Lead for Community Testing, and Larry Clyat is Technical Lead for the Acoustical Validation phase of the program. Thank you all for joining me today. I think the best place to begin, Kathy, would be with an overview of what the project entails.
The Low Boom Flight Demonstrator project is part of the Low Boom Flight Demonstration mission. And the overall goal of the mission is to provide community response data to a low sonic thump that is resulted from the X-59. The X-59 project is responsible for designing, fabricating, integrating, and then doing both ground and flight testing of that vehicle, and then supporting the other activities in the operation of that vehicle for the acoustic noise validation.
In talking about the QueSST aircraft, this is quite a different animal from what we're used to seeing in modern aircraft design. Larry, what are some of the ways the X-59 is designed to quiet the boom heard on the ground to more of a sonic thump? I believe bringing the noise down to about 75 decibels, or the equivalent of a car door slamming 20 feet away.
Yeah, to understand that, you have to know what makes a sonic boom in the first place, fundamentally. So a sonic boom is generated by the shocks that are coming off of an airplane when it's flying supersonic. And those shocks are generated at the airplane when the volume of the airplane changes, and the more abruptly that volume changes, the stronger the shocks. And so all of those shocks together is what's going to make that sonic boom. So that being said, the design mitigations for QueSST is to prevent those abrupt volume changes in the airplane itself. That's why we have a very long airplane, so that there are no abrupt volume changes. For example, from the tip of the nose of the airplane, where the volume is pretty much zero, to the cockpit, it has a very long nose to make that volume change very smooth and continuous. You're still going to have shocks, but you want to avoid those shocks coalescing and combining to make stronger shocks. So as those shocks propagate to the ground, QueSST is designed so those shocks stay more or less parallel and don't combine together to get a loud shock on the ground.
So you're smoothing out the booms then?
That's a good way to look at it. And there's also other design features that help make the sonic boom quieter, or make a sonic thump rather, which is we have a miniature T-tail that will attenuate the aft shock signature. We also have wing shielding, we call it, in front of the engine inlet to avoid what we call spillage, which also can add to the shock structure of the airplane and make a sonic boom. And of course, we just want a sonic thump as well. And it is good to note that this entire plane from tip to tail has been designed specifically as a demonstrator for quiet sonic boom. So nearly every design feature you're going to see on this airplane was put there to minimize and mitigate the sonic boom and to make a sonic thump. It's a very multi-dimensional problem. Altitude plays a role, weather conditions play a role, which way the wind is blowing plays a role. So it's a very complicated solution.
And one particularly important aspect of finding that solution is soliciting feedback from communities. Gautam, please tell us a bit about that process.
Well, we're planning on conducting between 4 to 6 tests around the U.S., starting in 2024. We're in the process of evaluating a lot of different candidate locations and airfields, taking into account a multitude of different factors, such as the ability of the X-59 to be able to operate from a given airfield, what kind of population centers are there in the area, the mix of rural, suburban, or urban environments, plus the overall climate and the weather at certain times of year in different regions, since all those can also influence the level of that sonic thump. Now, when we do make those decisions, certainly there will be outreach to local governments, the public services, and the general public in advance of those tests, both to provide a lot of the general information to everyone so they're aware of the overall test, but also as part of that process to get survey participants to participate and provide us their feedback to those sonic thumps.
We'll have more in just a moment, but first, this word from NBAA.
NBAA Flight Plan listeners, you get your weekly news here. Are you getting the latest daily headlines? The NBAA Insider Daily News Service puts the news you need in your hands every weekday morning, free of charge. Don't miss out. Subscribe today at nbaa.org/daily.
We're back now with Kathy Baum, Larry Clyat, and Gautam Shah, management and engineering leads on NASA's Low Boom Flight Demonstrator project that aims to lower the sound and intensity of sonic booms that reach the ground, which could ultimately enable supersonic flight over land. Gautam, this project is somewhat unique in that NASA is actively reaching out to communities for their feedback as part of the program. Why is that feedback so important to this effort?
Well, one of the goals that we're looking for is to generate the right amount of data to be able to provide to regulators that they can use that to make determinations of what a noise limit might be for overland supersonic flight. So in order to do that, we want to provide data that's going to be representative of the public to reflect what their real opinions are. And so it's important that we engage with public that are not accustomed to sounds from supersonic flight. And that's the reason for conducting these community tests, so that we get that more objective response from a range of people across all demographics, different living and working environments, as well as different climate regions around the country. There are several companies that are currently developing supersonic aircraft. Many of them are still based on having supersonic flight over water and not necessarily over land. The time frame for us to provide data to regulators such as the FAA and ICAO is in the 2027 timeframe. Complete our tests and provide the results to ICAO at that time for them to try to develop a specific noise standard. Once they've established that noise standard, then companies can use that to design their aircraft to meet that standard. And in addition to developing that standard, we're also participating in the efforts of how do you conduct those type of certification tests. How do you define the parameters for what a company or an aircraft would need to do to demonstrate that they meet certain noise levels?
Kathy, what's the timeline for the months and years ahead on the Low Boom Flight Demonstrator program?
So the first flight of the aircraft is actually in 2022. And the first flight for the community response testing will be in 2024, like Gautam mentioned. So between 2022 and 2024, we have the first flight, which is essentially going to be like a takeoff and then circle around and land, kind of as a traditional X-plane first flight. And then we will kind of expand the envelope, is what we would call it. So we're looking to make sure that the vehicle is safe, airworthy, and performs as we expect through all the regions that it's able to fly, up to and slightly beyond the target test point of Mach 1.4 or 1.4 times the speed of sound, or 925 miles per hour and 55,000 feet. So we'll go a little bit faster and we'll go a little bit higher just to make sure if we overshoot the test point at any point that the vehicle is still safe to fly in that region. And so we'll check out all those regions, and then we kind of transition to that acoustic noise validation phase where we make sure that the thump on the ground is what we expected, so that we can then transition to GOTM's community response phase.
Gautam, how will your efforts solicit community feedback?
That's all part of our planning that we're doing right now, and that's going to involve trying to develop specific survey questionnaires, look at different methods of how we ask those questions, as well as get feedback from the participants. Could it be via a smartphone? Could it be questionnaire? Could it be via computer? Those are all different methods that we're considering. So it's going to be quite potentially diverse methods of acquiring that data.
Larry?
I just wanted to kind of piggyback off of what Gautam said about how phase 3 will use diverse measurement systems and approaches. And phase 2 is very similar. That's where we will be validating the sonic thump of the X-59 QueSST airplane. A lot of different diverse measurement approaches. Obviously, we'll have to take ground level measurements to record the sonic thump and make sure it's as quiet as we planned and designed it to be. We'll be taking in-flight probing of the near-field shock structure of the airplane. So that involves 2 airplanes in the air at the same time, one of them actually measuring the shock structure in flight of the X-59 airplane. And we'll also take shockwave imagery somewhat the same way, with 2 planes in the air, one of the planes very close to the airplane actually taking pictures of the shock structure. So a lot of different measurement techniques will go into validating the sonic thump of the QueSST airplane.
So Larry, as we talked about before, the X-59 QueSST is really unlike any other aircraft flying right now. For example, it is so optimized for its mission that its thin nose precludes a traditional forward windscreen, relying instead on a forward view screen with augmented reality imagery. How might the concept's unique features ultimately translate into future commercial aircraft designs?
So like you said, this isn't a prototype, it's a demonstration, it's a concept for us to demonstrate, for NASA to demonstrate all the technologies, supersonic related technologies and sonic boom related technologies that NASA has worked on and developed with industry partners over the years. So that's what this airplane is. It's a culmination of all that work and us demonstrating that, yes, we are ready to build a tip to tail airplane that can fly supersonically and produce a thump on the ground. That being said, the general concepts that go into this design, like I mentioned before, about how some of the design factors help mitigate the sonic boom, those are concepts that will be used by industry partners for production type airplanes. They won't be a scaled up version of our demonstrator of the QueSST X-59, because designing a quiet supersonic airplane is very specific to that airplane's mission. However, the technologies that we are demonstrating will be carried over to industry.
Kathy?
All of this, like we said, is related to changing the standards to open up the market for future commercial supersonic flight, which will then transition to likely business jets first, and then the large transport aircraft that you and I would typically fly on. But it's very exciting that this first major barrier could be overcome once we provide the data from GOTM's community response testing. And that would open up the market and start on that trajectory to where all of us could be getting to your business locations much faster.
This really is a pretty amazing program, and we could spend hours delving into the technical aspects. Instead, I encourage you to visit the Low Boom Flight Demonstrator Project website at nasa.gov/X59 to learn more about the program and the QueSST aircraft. We should also acknowledge that supersonic travel faces additional challenges besides noise before becoming a reality. Those include high development costs and concerns about its environmental impact. That said, the move toward supersonic flight was further bolstered recently with the news that United Airlines intends to purchase 15 supersonic airliners from Boom Supersonic, with options on another 35 aircraft to enter service later this decade. NBAA's Emerging Technologies Committee was established to help drive such near-future technologies like supersonic flight, as well as to address challenges in their implementation. Visit nbaa.org/emergingtech to learn more about the committee's work in bringing these technologies to business aviation. And lastly, thanks to user Grenigan at soundbible.com for the sonic boom that kicked off this episode. And that's the latest from the National Business Aviation Association. Remember, you can subscribe to all Flight Plan episodes at Apple Podcasts in the App Store, wherever you find your favorite podcasts, including by asking Alexa or another connected device, or download them from nbaa.org. I'm Rob Finfrock. Thanks for listening, and be sure to join us next time for a new episode of Flight Plan.